Students, today we are going to see about the generating function. So the general term of the generating function is g of x is equal to summation k equal to 0 to infinity a k x power k. Okay, yeah. So this is the general term. So substituting that k equal to 0 in that a k x power k means what? A 0 x power 0 plus summation means addition. So a1 x power 1 plus a2 x power 2 plus etc. Okay, so already you know that anything power 0 value become 1. So a naught plus a1 x plus a2 x square plus etc. is the series of generating function. Okay, so now we are going to see one example. Okay, see the example. Use the method of generating function to solve the recurrence relation an is equal to 3an minus 1 plus 1, that n value become greater than or equal to 1, given that a naught value 1 is given. Okay, so using the recurrence relation solve by using the generating function method. So the given function is what? an is equal to 3an minus 1 plus 1. That n value, starting value is n greater than 1. Okay, so here in the term an 3an minus 1 is in the form of recurrence relation form. Now we are going to convert the generating function form. So generating function means what? Already we see that no, summation and ak x power k. So here a portion is there, then x power k, that is x power n. In that given terms n is given, so x power n is needed. So we can multiply x power n, that is multiply by x power n. So here the function is n, so x power n and summation term, and the summing generating function general term is 0 to infinity, but here n value given is greater than or equal to 1. So summing 1 to infinity, right? So what is the condition? Summation n equal to 1 to infinity an x power n. This is left hand side term is equal to right hand side is what? Summation n equal to 1 to infinity 3an minus 1 x power n, isn't it? Next third term is summation n equal to 1 to infinity x to the power n. Okay, so first condition, first step is over. But our generating function condition is what? N value starts from 0. Okay, so suppose n value is equal to 1 to infinity இங்க இருக்கு இல்லையா? So substituting this a1 x power 1 plus a2 x power 2, that series will come. So a1 x power 1 பதிலா we need extra a naught. So here, so this term, okay, instead of this term I can write summation n equal to 0 to infinity an x power n minus a naught. So check whether it is correct or not. Suppose here is what? A naught plus a1x plus a2x square plus etc. minus a naught. So a naught cancel means balance term is the previous term, n equal to 1 to infinity an term. Okay, it's like way here. Okay, here 3 is constant. So balance term is what? Summation n equal to 1 to infinity a n minus 1 x power n. So in that suffix term a n minus 1 x power n minus 1 na, the whole term we can create the generating function, but here x power n only. So already we know the basic concept. Base equal means power is addition term. So x power, so add, that is x power minus 1 plus 1. Suppose minus 1 plus 1 cancel na x power 0 va. Anything power 0? 1. So the previous value will come. So 3 into summation n equal to 1 to infinity a n minus 1 x power n. Here we need n minus 1. So we can add and subtract x power minus 1 and x power 1. Okay. The last term the same, n equal to 1 to infinity x to the power n. Okay. So left hand side over, the right hand side term is 3. See here, x power minus 1 into x to the power 1 na separate பண்ணோம்னா. So the x power 1 term I can write in front of this. So 3x summation n equal to 1 to infinity a n minus 1 x to the power n. Here 1 minus 1 na. So already I said no, base equal, so power can add. So n minus 1. That term summation n equal to 1 to infinity x to the power n. So this is our required generating function. Okay, see summation n equal to 0, here summation n equal to 1. Substituting n equal to 1 in the term, n 1 minus 1 is 0. Here 1 minus 1 also 0. So that series will become a naught x power 0 plus a1x plus a2x square, like that way. So here also one generating function will create. Okay, see here. So already given, our question is what? Given that a naught value is 1. So substituting a naught value here, summation n equal to 0 to infinity a n x to the power n minus a naught value 1. So this is already given in our question. So 3x summation n equal to 1 to infinity a n minus 1 x to the power n minus 1 plus summation n equal to 1 to infinity x to the power n. Okay, yeah. So next, what is the generating function? That is, its symbol is g of x. G of x is equal to summation n equal to 0 to infinity a n x power n. So instead of this, I can replace that generating function g of x. Right? So g of x minus 1 is equal to 3x. Here also one generating function. So here also we can write g of x plus that summation portion. See here, summation n equal to 1 to infinity x power n. I can write, substituting x power 1 means what? X plus next term is x power 2 and next term x power 3 plus up to infinity. So this is the last one. Okay, so that 3x g of x I can convert into left hand side. So g of x minus 1 minus 3x g of x is equal to, so in the term I can take common in x because all the terms are having x, you know. So by x we can take common. What is the balance term? 1 plus x square plus etc. Okay, so this is the binomial expansion, that is the rational form, you know. What is the condition? 1 plus x square plus etc. means the formula is 1 minus x the whole power minus 1. Suppose here 1 plus 2x plus 3x square na 1 minus x the whole power minus 2 will become. Okay, so here the left hand side in the three terms, first and third term g of x is common na? So g of x I can take common. What is the balance term? Here 1 minus in the third term 3x, balance is minus 1 having. Okay, so next g of x into 1 minus 3x is equal to x, that 1 minus x the whole power minus 1. I can replace that power minus 1 will become plus, means right, in divide. So that is x by 1 minus x. That minus 1 convert into this side means plus 1. Okay, so here we take LCM. So LCM means what is the condition? X, then multiply this one. 1 into 1 minus x means the same, 1 minus x divided by 1 minus x. Here positive and negative term is cancelled. Balance 1 by 1 minus x is the final answer. So therefore, finally, g of x is equal to that final term. Here the numerator only 1 is having, so 1 by 1 minus x is there. Then this left hand side 1 minus 3x convert into this side now, it will become divider, so 1 minus 3x. So this is our final g of x value. G of x is equal to 1 by 1 minus x into 1 by 1 minus 3x. So this is our function. So g of x equal to, so this is our function of, so how we can solve this type 1 by 1 minus x into 1 minus 3x. It's exactly partial fraction. Okay, yeah. So partial fraction in denominator, more than one function, one factor is having means using that partial fraction. So that is g of x is equal to 1 by 1 minus x into 1 minus 3x, right, is equal to what we can write in split பண்ணும்போது, that is the first term, that is 1 minus x and 1 minus 3x. Okay, so using partial fraction, that is in first, both are different factor, you know. So a by 1 minus x plus b by 1 minus 3x. So hereafter we using this function only. Okay, so 1 by 1 minus x into 1 minus 3x is equal to, so here we take LCM, 1 minus x into 1 minus 3x. So here what, a into 1 minus 3x plus b into 1 minus x. Okay, right. So next is in denominator is cancelled. So what is the balance term? 1 is equal to a into 1 minus 3x plus b into 1 minus x, right? So now we find that a and b value. Okay, already you know that common procedure, substituting x equal to any number. Suppose it will become 0 means value find out பண்றது easy இல்லையா? So here put x is equal to, okay, I will substitute x is equal to 1. What is the answer? 1 is equal to a into 1 minus 3 into 1 means 3. 1 minus 3 value minus 2 plus here 1 minus 1 0. The second term totally 0. So finally 1 is equal to a into minus 2 means minus 2a. So here a value is what? Minus 1 by 2. So a value we got it. Next b value. B value, so any number here x equal to, what is the possible? 1 by 3. 1 by 3 means 3 cancel, 1 minus 1 0. So that is one way. And otherwise put x is equal to 0. What is the left hand? 1 is equal to a into 1 minus 3 into 0 means 1 minus 0, that is 1, right? Next b is equal to 1 minus 0. Here also b. So 1 equal to a plus b is the equation. So already we know that, we knew that a value, that is 1 is equal to minus 1 by 2 plus b. B is equal to, here minus 1 by 2 convert into this side means plus. So 1 minus into minus plus 1 by 2. Okay, so here also directly we can write 1 plus 1 by 2 is equal to b. So I will replace this one. Okay, right. So b is equal to, here LCM 2 into 1 into 2, 2 plus 1 means 3 by 2. So a value minus 1 by 2, b value 3 by 2. So substituting a and b value in our that given terms. So here I will take that from letter 1 or equation, anything, any number you can give. So substituting 1 in a and b value, that is 1 implies, what is that pa? A value is then left hand side g of x. So g of x is equal to, right, what is the condition? A value is minus 1 by 2 divided by 1 minus x plus b value is 3 by 2 divided by 1 minus 3x. Okay, right. So here minus 1 by 2, in that 1 minus x, already we see that 1 minus x the whole power balance 1 na. So convert into numerator means what? 1 minus x the whole power minus 1, right? Here also same procedure, 3 by 2 1 minus 3x the whole to the power minus 1. Okay, so minus 1 by 2, this portion is it. Next, already I told no, minus 1 by 2 1 minus x the whole power minus 1. What is the expansion of this? 1 plus x square plus etc. Okay, so like that 3 by 2 into this one term is what? 1 minus 3x now. Instead of x we replace 3x, so 1 plus 3x plus 3x the whole square plus etc. Okay, yeah. So 1 plus x square plus etc. So this is the series. So now I change into that whole summation part. Summation part means what? Minus 1 by 2. See here, summation n is equal to 0 to infinity, right? N equal to 0 to infinity x to the power n. In second term 3 by 2, here is 1 plus 3x. So already I said no, instead of x we replace 3x. So that is summation n equal to 0 to infinity 3x the whole power n. So 3x the whole power n we can write 3 power n x to the power n. Okay, so in left hand side is what? G of x. What is the general condition of g of x? Summation n is equal to 0 to infinity an x to the power n. Okay, the sum is going to complete summation this one. So an x power n minus 1 by 2 summation term, then 3 by 2 summation term. Okay, so now we need the general term of that given recurrence relation. So general term now I will take that x power n. So starting la multiply பண்ணோம் இல்லையா? What is the multiplication term? X power n and summing. So here I can take that coefficient of x power n. So that is the final answer. Okay, so a n is equal to, what is the final answer? Coefficient of x power n. Okay, so coefficient of x power n in that generating function. Okay, so an is equal to coefficient of x power n in g of x. We will get the final answer. In left hand side is what? Left hand side, that coefficient of x power n is an. So same term. So an is equal to, in right hand side term is x power n coefficient, that summing also general only. Okay, so constant term only we will take. So minus 1 by 2, right? Next, in that second term 3 by 2 and x power n coefficient 3 by 2 and 3 power n. Okay, so this is our final answer. And also simplify that an is equal to, so common term 2 is common, so we can take LCM minus 1 plus here 3 power 1. Already I said 3 base equal means power addition. So 3n plus 1 I can write. Okay, so minus 1 plus 3 power n plus 1 divided by 2. So 2 convert into this side means here 2an is equal to minus 1 plus 3 power n plus 1. So here we need only an. So an is equal to, so 1 by 2 I can take common. Then positive term is what? 3 power n plus 1 minus 1. So this is our required solution. So our generating function. Okay, so an is equal to 1 by 2 3 power n plus 1 minus 1. So I think all of you should understand. Okay, I hope all of you understood. So the final term is an is equal to 1 by 2 into 3 power n plus 1 minus 1. Okay, now I will see one. I will show you an example. An minus 7 an minus 1 plus 10 an minus 2 equal to 0. N is greater than or equal to 0, and that given value a not equal to 10 and a1 equal to 41. Okay, now you can try this one. In next session, we will see one more example. Thank you.